Hello everybody. In this short presentation we're going to look at SQLite and how it's going to be used in Android and what are the classes we need to implement and what's the architecture, right? Alright, so the database that is behind the storage of data in Android is called SQLite, right? And it enables us to store data in a relational format, and it allows us to query data much faster than using flat files, which are much harder to query and so on. So in the Android system uses this small open source database called SQLite, and it's used in a lot of applications that you can that you are using. For example, Firefox, Chrome, Dropbox. A lot of applications use this kind of database. So it's a database system that can be used in applications, right? Okay. It's small. It's a small system, but it's fast. Provides powerful functionality, especially when you want to provide querying and storing. Okay, so now there are two main packages we need to think about or be aware of. There is the Android database, okay, and under database SQLite, which is mainly for SQLite implementations. Now, the organization is that there is an opener. SQLite opener is a helper class designed to manage the database creation and version management. So basically, when you create the database, or you want to trigger specific actions, or when you upgrade the database, you want to trigger specific action, or when the database is opened, you want to trigger specific actions. This is where you should do it. SQLite opener, it's a class that we have to extend to dictate what kind of implementations we would like to have with respect to different instances or different events that occur when the database is opened. Okay, we'll look at it in a lot of detail. This SQLite database that exposes, this is a class that actually exposes the SQLite database methods. For example, allows you to fire queries, allows you to manage the database, and actually to connect. After you connect to the database, you get an instance of that class, which is the SQLite database, and then you can use it to trigger SQL statements on the database itself. Then there is the table object. It's a wrapper class that we're going to implement to provide some abstraction with regard to the table. And then the data access object is also another abstraction that we were going to create, is to enable us to interact with the database for specific for specific tables. For example, we're going to write all our SQL statements here, our insert updates, if you want to interact with a specific table, then we are going to use this class to do this, to facilitate this kind of interaction. Okay, so basically what we're going to have is that there is an opener, and then the opener gives us a database, a SQLite database, and then we'll have a table object, and we'll have the data access object. As the name implies, data access object, it is the object that allows us to communicate with the database, and it does that through interaction with other classes, as we will see in a little bit. Okay, now the SQLite opener, okay, we need to extend that class to implement the following methods. The onCreate. This method is called when the OpenHandler class attempts to create the database for the first time. Okay, only when the database creates for the first time, this class is going to get called. Then that's probably the time when we want to actually create the tables and so on, right? This is where the creation of the tables, initial population of the tables with some kind of initial data if you need to, and so on. The onUpgrade is a method that is called by the handler when the database needs to be upgraded. And what's going to happen is that there is a version that you are storing of your current database. And that version is stored in two places, in your code and in the database file that gets created. So if in your code you bump up the version number, this is an indication that the database needs to be upgraded. And that will call the onUpgrade. Okay, and usually it is used to drop tables, add tables, do anything else that is needed to upgrade the new schema version. That happens in this class. Okay, now they will be called by the framework. So basically the framework will call the methods onCreate, onUpdate, and others as needed, right? The onCreate will be called if the database does not already exist, and this is the first time you're going to create it. The onUpdate will be called if the database version passed is higher than the current version of the database. The OpenHandler instance will be used to get the database instance by calling getWritable if you need a database that allows you to write. So it creates and opens a database that will be used for reading and writing, or you just can get a readable database, which is read-only database will be returned. Okay, so now the example that we're looking at is that we'd like to store notes in a database, And this is how the data is going, the table is going to look like. It has an ID, has a subject, and has a note. Okay, something like this: an ID column, a subject column, and a note column, right? So basically the ID is going to be the primary key, and the ID is going to be auto increment. I want it to automatically increment the ID, so the system takes care of the ID for me. I just provide the subject and the note, and I get to store it. Now the SQLite OpenHelper looks something like this. You create your own class and you extend the SQLite OpenHelper, and we'll look at that in very, very long detail in the next screencast, which we actually go and implement this, right? So basically what happens, I want you to pay attention to, is there is an onOpen, an onCreate, and onUpgrade, right? The only onCreate and onUpgrade are required. But anyway, in the onCreate, what we're doing is we are actually calling the notes table, which is a representation of that table. We are calling its own onCreate, and you could see that there is an instance of the DB. See, the DB is in all of them, and that's an instance of the SQL database if it's opened, right? And the onUpgrade, when it's called, we'll call the onUpgrade and onCreate, and we'll look at these details in a little bit, right? Now, the notes table is basically, we have here a representation of the name of the table, the column IDs, the column names, the ID, the subject, and the text. And basically here is the onCreate function that we created here. And the onCreate, actually we use a string builder so that we could build the string that looks like this: create table, and these are there's an auto increment ID, and then there's a subject and a note, and here it is. And you can see here we're using the DB to actually execute the statement. And similarly on the onUpgrade, we'll drop the table if it exists, and so on, right? So that's basically this. Okay, now you got an idea of what this notes table, it's basically just to represent the table, right? Now, to represent an object in the table, we create the note class, and that note class allows us to have, it has an ID, it has a subject, has a text, and so on. That's the note class. And the note class is just a simple class that holds the note data, right? Now, the data access object is an object that we're going to create that will allow us to actually to communicate with the database with regards to anything related to notes. For example, you can save a note, you can update a note, you can delete a note, you can get a note by ID, you can get all the notes, and build note from cursor is a mechanism of creating a note from a cursor. So basically we'll look at what these cursors are in more detail when you look at the actual implementation of it. But anyhow, what happens is that when you query the table, when you create the database returns a cursor. The cursor is not pointing at the first entry in the result. It's pointing before the first entry in the result. And then you use that cursor to iterate over the results, right? And then use the cursor to retrieve data if you are pointing to a result, right? So this is what the notes DAO is going to look like. And this is some of the implementation. For example, when you want to save a note, you pass on a note, you use this content value, which is a key value pair. You basically provide the column name and the value, and then you use db.insert. Then you tell it what's the table name, and then you pass it the value, right? And that's how you save. To update, it's exactly like the save, but there is a query, because db.update requires you to provide which ones to update. So that's what we are using here. We are using the column ID equals question mark. This question mark is a parameter that's being provided by the next array. This is an array that has the parameters that need to be replace these question marks, right? And here we only have one parameter, so the array only has one entry, and it is the note ID, right? So that's the update. And the delete is very similar to the update, but the delete does not provide any values. Just say which ones you want to delete by providing a query. All right, so that's how you delete. And then how do you get, I want to get a specific note, and basically you do db.query, give it the table name. This is an array of columns that you want to retrieve. This is the projection part of the query, which is the select statement, the select part of the query, right? And you tell it what columns do you want. And then this is the where clause of the query, where you tell it what is the condition of what you want to return back. And this is the query part, and this is the query arguments. Okay, so we are looking by ID. And then you have group by, you have order by, you have having, and so on, anything related to the query. So basically when you get a cursor, you can move to the first. If you move to the first, so the cursor comes back with one entry, for example, or multiple entries. The cursor is not pointing at the beginning at the first entry. It's pointing before the first entry. When you tell it to move to the first, it moves to the first entry. If there is a first entry, that returns true. If it's not, then it's to return false. And basically what we're doing is that we're just getting the cursor, move to the first. Now the cursor is pointing to the first. Then we use the note, retrieve the note using the note from build note from cursor, and we pass it to cursor and it returns back a note, and we look at how to do that. Similarly, get all is very similar to getting one note, but instead we don't have any where clause. So basically it's the same story. You have the table name, you have the columns that you are interested in, and everything is null at the end. You have 5 nulls. Here you didn't have 5 nulls, you had only 3, and then these 2 parameters were the query and the query arguments. And we don't have any query and query arguments, and that's going to return all the nodes, right? So basically that's why the cursor comes back here, and we're going to use a while statement. While move to next. Basically move to next will return true if there is a next, and it will return false if there is no next. So that's what we're doing here, and then basically we're getting a note based on the cursor, and then we add the note to the notes array, and we return the notes array. Now, how do we retrieve stuff from a cursor? Given a cursor, we just say cursor.getLong 0. That 0 is the index of the column. See here the columns, the first column at location 0 is the column ID, is the ID. And then it's the subject, and then it's the text. That's why you will see here 0, 1, 2. So basically 0 is to identify this is the first column, second column, and third column based on what you have written in your query, right? And you can get a string, get a long, and so on. So that's how we get the note, right? So now we looked at the DAO, which has all these functions that allow us to query the database. And then you can also now after using the DAO, we have a wrapper class which is called the data manager, right? Which we are going to include some of the it will be used to create or update the database, maintain the database instance. It's used to call different access classes with DAOs, and it also can be used to close the connection. All right. So this is our data manager. It's very straightforward. When you create it, you pass it the context. It opens the database, it creates an instance of the database, and creates an instance of the DAO so that we could use it. And then you could say get the DAO. It returns back the DAO, and you can use the DAO. Right now. After you do all of that, now if you want to inspect the database, what happens is that the database is created and is stored in a folder inside the emulator or inside the device under data, package name of your application, and then databases. It's a file. So you can download the file into your computer and then use some SQLite tools to actually query it. For example, there is a very popular one called the DB browser for SQLite, and you can download it there. And basically what happens is that you use the device file explorer, right? And can come here, and they will demo this in a separate video. But anyway, you can download that file and then you can open it. And then here you could see I could query and look at the structure of the database and so on. And we'll look at that in more detail in the demo part of this topic.